The broadcast is now starting. All attendees are in listen-only mode.
All right. Good morning, everyone, and welcome to the November California-Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thanks to those of you that have joined us previously and then those that are joining us for the first time. My name is Amanda Sheffield, and I am at Scripps Institution of Oceanography in San Diego. I'm a Regional Drought Information Coordinator for NIDIS in California, Nevada. Today, we've got a great webinar set up for you guys to start talking about further how this winter may turn out, how the winter is going so far, and a couple presentations from our partners on preparing your winter toolbox and tools that are available through a couple different programs, including the NOAA RISA team and the California Nevada River Forecast Center. This bi-monthly webinar series is designed to provide California Nevada with this timely information on the drought status, if there are any impacts, as well as a preview of developing climatic events. This webinar is co-hosted with the California Nevada Applications Program. It's a NOAA RISA program based at Scripps and in Reno at the Desert Research Institute. Before we get started, I also want to mention this webinar is being recorded, and a recording along with a 2-page summary will be available on drought.gov later this week. And before we get too deep, I just want to mention a little bit again about NIDIS for those who haven't joined us before. NIDIS is the National Integrated Drought Information System. Our mission is to improve the nation's capacity to proactively manage drought and help those that are affected by drought by having the best available information and resources to talk about assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. And we work through this by working towards building a national drought early warning systems. On the screen, you can see the different regional drought early warning systems we've launched, realizing that droughts is different everywhere in different parts of the country. Each drought early warning system is basically a partner network of a wide range of federal, tribal, state, local, and academic partners that work to make this climate and drought science information available, easily understandable, and usable for decision making. And so that way we can better prepare regions in drought across all these different topics, including how we observe drought, monitor drought, conduct research, communicate it, things like that. Different than previous webinars, for those of you who have joined before, I've got a few quick announcements related to the DEWS I wanted to make before we get started. There's quite a bit going on this time of year, and so there's a few with partners have sent along my way that I wanted to mention for you guys. The first one is on December 5th. There's a workshop that the Department of Water Resources and the Water Education Foundation are hosting up in Irvine, titled What a Year, it should be, say, 2018 Feast or Famine. And they are going to focus in on what's our ability to actually predict winter precipitation. If you're in the Reno area or in the Great Basin area, on December 6th, CNAP is hosting their annual Great Basin Climate Forum, and you can register on the CNAP website or head over to the DRI website. And recently, given a lot of the wildfires that have been going on the last few years, including this year, NIDIS and the Western Regional Climate Center have collaborated to release a drought and wildfire strategic plan. So activities that we could do to hopefully improve drought information use by wildland fire management and how we can help them with what they need to do to better serve the community around wildfire. A few other quick ones. Following last year's snow drought conditions that we had in the Sierras in the West, we launched with many partners a snow drought page on drought.gov. It is up and live and running again. There you'll find a little description of what is snow drought, tools, and also current conditions that we're going to update monthly to start with throughout the season until we see how the snowpack's building and things like that. Another quick one I thought folks would be interested in. Previous webinars, we've had EDI on here, the Evaporative Demand Drought Index. Recently, they've actually added forecast maps of EDI with the NOAA National Center for Environmental Information. And you can see the links there. And it's providing 1 month EDI forecasts on their website now, which was an interest of the folks in our region, especially and in other regions. So we wanted to share that. Go ahead and share that. Oh, there's and then one more thing. Oops, here we go. We are working with a couple partners that do the FEMA THERA process, which is basically a risk assessment tool for FEMA related to drought. And partners have developed a drought toolkit. They'll be going with that tool this Thursday from noon to 1 p.m. Central Time, so 10 to 11 a.m. Pacific Time. And they're going to highlight the toolkit and how you can use it to better if you actually are working through this FEMA THERA process related to drought, or if you are just drought planning in general. It's a tool that will be helpful to better prepare and plan for drought. And last one, if you are a public health professional, we are working towards we wanted you to save the date for a workshop we're having in February. Basically, there's a new CDC resource guide on preparing public health professionals for drought, and so we're working on a workshop that's California specific to talk about these impacts and learn more about the resource guide. And so more information will be coming soon on drought.gov. I wanted to give folks a heads up if you like to save the date, especially if you work with public health professionals. With that, I'm ready to pass it over to our first speaker. So our first is going to be the Drought and Climate Update that we traditionally do. Julie Clancy is going to be giving that presentation. She's the CNAP Program Manager as well as Operations Manager for CW3E, which you'll learn about more later. And with that, I'll pass it over to Julie. Julie, you there?
Yep, great. Thanks, Amanda.
And there we go.
Great. So thanks for having me today. I am in the 15 minutes for our climate and drought update. I'm going to try and cover the drought status, talk about the temperature, precipitation, and snow status in our region in California and Nevada, and then end with a really brief overview of current sea surface temperature conditions, the Colorado River Basin, and then just one slide that talks a little bit about the November pre-fire conditions prior to the Camp and Woolsey fires. So it's a lot to cover in 15 minutes. It is a relatively high-level overview, but all the links are in the slides if you want to dig into the information more afterwards. So the current drought status, this is from the U.S. Drought Monitor that came out in on November 20th, so the week before, just last week. And as you can see, there's some areas in our region, especially up here in the Upper Klamath, in Santa Barbara and Ventura counties and Imperial County, that are in extreme drought. Other areas, Southern California, coastal Southern California, eastern northern Nevada are in severe drought. And then throughout much of the rest of the region, we're either in moderate to at least abnormally dry. So there's nothing white on the map currently. This is just a brief look to see how it changed from mid-November to the current drought monitor. And this yellow indicates a degradation, so an indication of more drought. And this is where you see the degradation in Ventura and Santa Barbara counties, and then throughout much of central coastal California up to northern, in through the northern Sierras and northern Nevada. So just as a, just as a quick comparison to see how this changed since the beginning of the water year, most of the changes happened actually in this last week, except there was some more degradation or more drought in the northern Sierras through here. And then also we saw a little bit of drought improvement in the far eastern parts of Southern California. So briefly talking about temperature, what you're looking at here is since the beginning of the water year. So water years start October 1st and they go through September 30th. And so this is looking at the daily maximum temperatures for our region from October 1st through November 19th. And what you can see is throughout a lot of California, it's a bit warmer. The maximum temperatures are a bit warmer than average. since the water year began, whereas lots of areas of Nevada are actually a bit cooler, and also eastern Southern California areas. If you compare that to T-mins, or the minimum temperature in a day, those are about average. You know, they're between -2 and 2 degrees throughout much of the region, with the exception of a very cool north central Nevada area and a relatively warm Southern California coastal area. So this is looking at precipitation in the region before the Thanksgiving storms that we just recently have. So this was through November 19th, so I guess Monday of last week. And as you can see, and I think most of us have experienced in the region, it's extremely dry. So this is percent of normal average precipitation for this time of year. And these really dark red colors are less than 2%. The bright red colors are between 25 and 5%. And so much of California and northern Nevada were at least below 50%, if not much drier. There are some exceptions to that. The far eastern part of Southern California, we had a couple East Pacific hurricanes come through and deliver quite a bit of precipitation that was a bit abnormal for that time of year. And then also part of central Nevada is a bit above normal. So this next figure is looking at the number of days with above a ½ inch. And this really dark red color indicates that most of the region has had less than 2 days with above a ½ inch. And this was up to November 19th. And now what I'm going to do, this was before those Thanksgiving Day storms or Thanksgiving weekend storms, and then this is looking at after. And so what you can see is that these storms brought some precipitation, and so we're still below normal for much of the region. In California and northern Nevada, eastern Nevada is doing a bit better in terms of precipitation, but we're a bit below normal for much of the region. And next one is just looking at how much precipitation in the last 7 days fell. So how much rain did those Thanksgiving Day storms really produce for our region? And throughout much of California, you can see this is in inches, and here's the air bar. This is from the California Nevada River Forecast Center. So much of the region was below about 2 inches along coastal California. There were some higher values, and the northern Sierras got up into almost 7 inches, and also I'd say far northern California. So some areas did get a decent amount of precipitation over the last week, and other areas, it was 2 inches or less. So this is just looking at the snowpack after these storms, and so this is the current, as of today, percent of normal from various different stations that are reporting in California and Nevada. This again is from the California Nevada River Forecast Center, and so what you'll see here is these maroon colors are below 50%, and this is looking at SWE, so which is snow water equivalent, of how much water is being held in the snowpack. And then there are a couple though that are in the northern Sierras that are doing near average, or some that are doing exceptionally well. None of these stations, I don't think these have been quality controlled yet, but overall it is relatively low, especially in the southern Sierras here. So this is reporting on the snow water equivalent in inches, so how much snow is actually being held in that snowpack. And so from 0.1 to 10 is this light blue color, and so under the light blue cover you can see a lot of zeros. But other words, if you look at these numbers, I realize they're a bit small, but most of them are between 1 and 3 inches throughout. And then in Nevada, a lot of them are below 2 inches. So what does all this mean for water supplies? And so this is from Mike Dedinger. It's on the CNAP website. And so I think many of you that are returning viewers have probably seen this before because we show it most winters. But what the bottom line is the water that are stored in 28 daily reporting Western Sierra reservoirs. So this is focused on California. You can see the red dots here where the reservoirs are located. And the red line is where we are as of last night or this morning. And then if there was much of a snowpack, we would see the orange line. So you could see that where the reservoirs were and how the snowpack, because the snowpack holds the water, is relative to where the reservoirs are. So this was as Mike kindly did this for me this morning so I could update everybody with the latest information. However, the snow levels just haven't updated on the computer end. And Mike did a best guess that, you'd maybe just see a little orange dot here, given that there's relatively low SWE throughout much of this year. So this is looking at Lake Tahoe. So this is going back to October 2016, so that really, really dry period. So I went back that far to be able to see how we compare to now. So this is where we are currently. So just the gauge height is just below 7 feet, and you started to see a bit of an increase over the weekend. So it ticked up just a bit. We are lower than where we were, or Lake Tahoe is lower than where it was last year, but it's still much higher than where it was during the drought. So it just gives you some perspective of the Lake Tahoe level. So I don't want to take anything from the outlook, but just in the 7-day forecast, what's the chances of more precipitation hitting our area? And I'll talk about this a little bit more when I talk about tools, but this is the probability of an atmospheric river, an AR, hitting the coastline. And it does look like that, at least for, well, Oregon and Washington will likely get some precipitation from the AR, but as you go even farther south, some of that will come down and hit California. And then potentially for central to southern California, having an AR hit later in the week is also quite high. So moving on to touching on a lot of different topics. So this is looking at the Colorado River Basin. This is an update that the Metropolitan Water District does weekly. This was as of November 19th, so as of last week. It is the Upper Colorado River Basin right now. The snow water equivalent, or the SWE value, is 81% of normal. It is a bit lower, and as you can see in the western watersheds, it's 80% or less, and in a couple of the eastern, it's a bit higher. And then here's looking at Lake Powell and Lake Mead on the Colorado. Lake Powell is, so this is where we are this year. And we're much lower than where we were, Lake Powell was at the beginning of last water year. So it's calculated at 3.82 million acre feet less in storage this year than last year. Similarly, Lake Mead storage levels, you can see the line here, and it's 181,000 acre feet less than the previous year. So the SWE, or the snow water equivalent, is a bit below normal, but not extremely low. However, the two largest reservoirs and the main reservoirs for the Colorado River and the lower Colorado River are lower than they were last year. So this is looking at current sea surface conditions. I want to point out a couple things. First, right here, you see these relatively warm temperatures, so about 2 to 2.5 degrees warmer than normal for this time of year. This is in Celsius. This is right around the equator, and so this is what you'll see is El Nino 3 or 3.4, and this is El Nino 4 region. So this is an indication that the tropical Pacific is leaning towards an El Nino conditions. However, if you look up here in the northern Pacific, you see extremely warm temperatures, especially in the western Pacific. And so how all these different warm temperatures, and then also with some of the colder temperatures in South America, how these interact to affect our weather is, there's a lot of uncertainty around it, and there's a lot of different possible outcomes. So the last thing I was going to touch on real briefly is the fuel and weather conditions in early November before the large fires that we experienced here in California. And so Amanda mentioned this in the beginning, but this is the eddy for the week of November 10th, the week that the fires were started. And so what eddy, you can think of it as eddy as being really the thirst of the landscape. So it takes into account temperature, humidity, wind, precipitation. And as you can see throughout much of Northern California, where the Camp Fire was, it's extremely dry, and the landscape is extremely dry. Down here in LA, it is dry. It's in the 95th to 98th percentile, maybe slightly less, but the Northern California was extremely dry. So this next figure is looking at the fuel, so it combines dead fuel and live fuel. And there's a lot going on here, and I think the easiest way to describe it is if you look at the blue line. So this is the amount of fuel available and the current conditions. And so this arrow is pointing to right before the campfire started. This is for the Sacramento Valley foothills region. And the red line is the historical maximum. And so what you can see is right before the fire started, the fuel loads were incredibly high. And this is showing for the Sacramento area where the campfire was. But it's a similar, they show some of the things not quite as high for the Wolseley fire. So, and this is from Climate Engine right here. It's showing a 3-month period, or sorry, a 2-week period of anomalous wind speeds. So this doesn't even account for the gust, and it's averaged over time, but you can see above in the Sacramento region where you see those really, there was some anomalously high winds, and also down in the Thousand Oaks, Los Angeles region. And so it just was one of the climate conditions, or the weather conditions, were at a point where you had a very dry landscape, which caused these really high fuels, and then the winds, which we've been reading a lot about in the news, unfortunately. So this is just a brief summary. Much of California and Nevada, even after the storms, are still dry, about 50 to 75% of normal. There are some exceptions to that. The recent rains helped, and more rains is forecasted for this week, which will hopefully help alleviate some of that dryness as well. So far this year, Tmax is a bit higher than normal, with Tmin right about average. The upper Colorado is at 80% of normal for snowpack. There is an El Nino sea surface temperature, or El Nino pattern based on sea surface temperature in the tropics, but there's also a very warm North Pacific. And then, as I mentioned just now, the high fuel load and extreme dry conditions prior to both the Camp and Wolseley fires. So that's what I have for the summary. Amanda, can I turn it back to you?
Yes, totally. I will just grab control real quick. And I forgot to mention before we got started is that we'll be doing questions towards the end. So go ahead and type them into the questions box if you have them along the way for any of the speakers, and we'll address them later on. Right now, obviously, Julie just gave us the update, so we're going to look for the outlook next. The next speaker is Michelle LaRue. She's with a meteorologist with the National Weather Service Climate Prediction Center. And I'm going to go ahead and pass and bring up her PowerPoint, and we'll go ahead and get started. Here we go. Michelle, just let me know when you'd like me to change slides.
Okay, yeah, thanks. I appreciate you doing that. And thanks to everyone for calling in today. So go ahead to the next slide. So the big news right now, at least in the climate community, is that we are currently in an El Nino watch, and we've been in an El Nino watch since roughly about July of this past year. We are seeing a bit of a delay in the onset of El Nino. We had anticipated it to form in the fall, and now we're still kind of watching it get its act together. But at this point, we expect it to form imminently and then continue through the Northern Hemisphere winter. There's about an 80% chance of that happening, and then also into the spring. Next. Go ahead and click, yeah. And this is important because for the California and Nevada region, El Nino can, it doesn't always, but it can bring beneficial rain and snow, and potentially this could help alleviate the drought in the Southwest. Next. So just a quick reminder, we are monitoring the El Nino Southern Oscillation, or we call it ENSO for short. And there's two kind of extremes in ENSO. There's an La Niña, which is on the top there, and that's when you have colder than average waters in the central and eastern tropical Pacific. And then, of course, El Nino, which is shown on the bottom there, that's when you have warmer than average waters in the central and eastern Pacific. Next slide. If you look at the tropical Pacific right now, or at least that of the sea surface temperature anomalies over the last month, what you see, and our previous presenter also showed this, is a lot of those yellow and red shadings, which is indicative of above average sea surface temperatures. Now, I do want to sort of point out a difference. You know, in this previous slides, there was mostly above average sea surface temperatures in the eastern and central Pacific, but we're actually seeing a really, really wide expanse of above average sea surface temperatures going all the way into the western Pacific as well. And this is interesting. We did see this in 2014. We're a little nervous that we're seeing an evolution similar to that particular year. And for those who don't have a library of past El Nino events in their head, that was an imported El Nino that did not form. At this point, we're still favoring it to form, but we do need to see some more indicators that there is an ENSO in place, because ENSO is not just the ocean, it's also the atmosphere. Next slide. And it's important to get the atmosphere engaged, because that's what ultimately gives us impacts over the Pacific and North America. This is a schematic, so it's kind of a cartoon drawing of typical El Nino winters. And it's important to keep in mind that not every El Nino winter is the same. We just want to see the general overall pattern, and we play those up using what we call probabilities. So when I show you the outlooks, I'll be showing you probabilities, meaning, you know, what is the percent chance that it'll be wetter or drier or warmer than average. And that's because of these differences between El Nino events. But in general, El Nino will lead to this kind of extended Pacific jet stream, which is shown by the red arrow there. It really amplifies the storm track across the southern tier of the United States, and that can help transport in moisture and precipitation across the southern tier of the United States, including Southern California and also parts of Nevada. Next slide. So fundamentally, though, in order to get the jet stream active and everything going, we do need to see a change in the tropical rainfall patterns. So previously, I was emphasizing sea surface temperatures, but ENSO is both the ocean and the atmosphere together as a coupled pattern that feedbacks onto each other. And this coupled pattern is important because we can't really impact the jet stream unless we change the patterns of rainfall in the tropics. So on the bottom left there, I'm showing a picture of a strong El Nino. This is just one particular case where you get wetter than average conditions in the central and eastern Pacific and drier than average conditions over Indonesia. And so this dipole is very much indicative of an El Nino. So right now, though, we're seeing something that is, sort of resembles an El Nino, but it's shifted from its normal position. In other words, we're seeing, and unfortunately I'm flipping variables on you. So in other words, on the left I'm showing precip, on the right I'm showing a proxy for precipitation called outgoing long wave radiation. The details aren't important other than to point out those reds and blues there indicating on the right hand side drier than average conditions, which is, you know, consistent with El Nino. And then the blue there, and you can see it in the western tropical Pacific, is wetter than average conditions. And so we need to see those wetter than average conditions shift a little bit further to the east. It's not really triggering a region that's sensitive for the jet stream and to get the teleconnections going over the Pacific North American region. So we'll be watching that very closely coming up here, because we need to see convection look more like the pattern in the left side. Next slide. So when we're determining whether we're currently in El Nino or not, we go through this little flow chart to determine whether we think conditions have become coupled. That is, both the ocean and the atmosphere are responding, and we're expected to see those impacts over the Pacific North American region. And so the first question we ask is whether a certain region of the tropical East Central Pacific, what we call Niño 3-4, but that's the details of that aren't important. Basically, we want to see those become warm enough. And right now we can definitely say yes, the sea surface temperatures are warm enough in that particular region. We also, the second decision point is, do we think that the forecast will persist? That is, that it will stay warm enough for several seasons. And right now we can say yes. And then the final step to declaring whether or not we're in an El Nino or not is, what does the tropical Pacific atmosphere look like? And as I just showed you in the previous slide, right now we're not seeing exactly what we want in terms of tropical convection patterns or rainfall patterns. And we look at other measures like the Southern Oscillation Index, which is difference of pressures, and we have some other indicators of tropical Pacific atmospheric response. And right now, go ahead and click. We can say for sure that is not responding, and so as such, we have not declared El Nino. It's not enough just to have it in the ocean. We also have to see that atmosphere click in and engage. So right now, we're waiting on the atmosphere. Next slide. So here are the probabilities of basically ENSO coming up here through the winter and into the spring. And as I stated earlier, we're fairly confident. There's an 80% chance that it will, these red bars are showing 80% chance that El Nino will continue through the winter here and then into the spring with a 55-60% chance. Now, to really emphasize this, and unfortunately this is climate prediction, meaning we tend to be less certain about climate than we are about weather. And so this 80% chance of El Nino forming does come with a 20% probability that El Nino will not form, right? And so a 1 in 5 chance that it will not form at all. And so you have to keep that in mind for your decision making, because we are all doing this with respect to probabilities. All right, next slide. So here's another way to look at impacts associated with winter precipitation departures. And here the green blue means above average precipitation, and brown and reds mean below average precipitation. And this is typical, so this is average El Nino response. But again, I don't have time to get into it, but the El Nino events can vary considerably from each other. So not every El Nino winter will look like this pattern. But in general, you see the above average rainfall across the West Coast and also across the Southeast. Next slide. And this is showing the temperature pattern, where blue is below average temperatures and the yellow and reds are indicating above average temperatures. So this is generally what we expect with regards to El Nino during the winter. Now, El Nino, of course, is not the only thing that the Climate Prediction Center looks at when we make our forecast. Next slide. We also look at what we call long-term trends. And so when we do that, when we look at both El Nino and the long-term trends in temperature, we notice above average temperatures across a large swath of the West. So if you look at our temperature outlooks, they look a lot more like this particular pattern. And so I just wanted to show you that difference, because it's not just El Nino that we're playing up here, we're also playing up the trends. Next slide. So here's the official outlook coming from the NOAA Climate Prediction Center and the Weather Service. And if you look on the right panel there, and this is for December, January, and February average. And so the temperature pattern there, again, is in terms of probabilities. So the red there is the chance that it will be above average temperature. And as the previous slide sort of suggested, we are playing the above average probabilities. That's why we have a lot of those oranges and red colors over there by the West Coast, because we expect some combination of El Nino and trends to be playing a role this winter. When you look at precipitation, and this is an adjustment from our October forecast. So we make these forecasts every single month. So that means the maps can change depending on the latest information. And this is the forecast we made in mid-November, so right before Thanksgiving. And as such, we did actually increase the probabilities that we would see above average precipitation across California and into southern and western Nevada. These are not huge probabilities. These probabilities, that lightest shade means that it's about just slightly north of 33% probability. And so that's reflecting that three category system that we predict. So in other words, if there was equal chances between all outcomes, it would be 33% for each outcome, because we have three options. It can be above average, it can be near average, or it can be below average. So equal chances, that EC that you see over Oregon and Washington, means that we can't say one way or another which category is favored. But we are just slightly tilting toward the above average precipitation category for precipitation in California and Nevada there. However, if you go to the next slide, this quickly goes away for California. So if you look at the January, February, March average outlook, we still enhance the probabilities for above average temperature, but we drop it entirely from California and Nevada, instead replacing it with EC, meaning that equal chances. We're not sure what's going to happen there. In other words, your best bet is something associated with the historical averages or climatology. There's just not a lot of strong signals. And part of that is because this El Nino that we're looking at doesn't seem particularly overwhelming at this point. And if it does form, it'll probably be on the weaker side of things. And as a result of it being weaker, it's not going to have as much of a forcing or a push on the jet stream and the downstream impacts. So we're really backing off as we get into the winter on precipitation. At this point, we're just not seeing strong signals. We did put it into December, January, and February. I talked to the seasonal forecaster today, and part of that was because of the expected short-term forecast. That is, we're looking at the next couple weeks going out to a month. And the pattern looks to be wetter than average for California. So that short-term forecast is one of the reasons why the December, January, February average is slightly tilted toward wet, but not the January, February, and March outlook. Next slide. So in general, we have a watch right now. Yeah, ocean looks good. Atmosphere, we're still on hold. And we have an 80% chance that El Nino will emerge here in the winter, and then slightly less chance as we get into spring. And that's the expected El Nino evolution. El Ninos tend to peak during the winter and then decay or weaken into the spring. There are two links there that I hope you will check out. The ENSO diagnostic discussions updated once a month, the second Thursday of each month. So check that out. And also the ENSO blog, which is kind of our user-friendly way of conveying El Nino and La Niña information. We've been doing this about 4 years. We update twice a month there. So if you have an interest in El Nino, please check out our blog. All right, thanks so much.
Great, thanks, Michelle. And I second checking out the ENSO blog, especially if you guys are just curious about this. They have great explanations of what's happening and how the atmosphere is reacting to the ocean and things like that. So I second Michelle's that if you're interested more in this, check that out. Okay, right now I don't see any quick questions, so I will just go back then to our next set of the agenda for the webinar. The next part here is going to be about preparing your winter toolbox. First, we're going to have Pete from the National Weather Service California Nevada River Forecast Center. There, he's the service coordination hydrologist. He's going to give you a quick tour of their tools and what they have to help you guys better prepare for having these tools at your fingertips as we move through the winter and start, so that way you can see how things are going. And with that, Pete, I'm going to pass control over to you.
All right, can you see that screen?
Yep.
All right. Again, I'm Pete with the National Weather Service, and Julie already kind of gave us a little preview of some of the things I want to show. Our website was kind of been in evolution for many years. I've been here about 20 years, and the original design of the website was kind of to help us as river forecasters to keep on tabs of where the precip is falling, how the rivers are reacting. Our office kind of has two primary objectives. One is river forecasting for flooding, but because we run these hydrology models for flooding, we also produce forecasts for long-term water supply to our reservoirs. And so as you look at our website, the first thing you'll see is a map with our river forecasts, which may not have a lot to do with drought, but if you're interested in what rivers are doing in your local area, it's a very helpful place to look, and you can see quick tabs or windows of what's happening on different rivers, both for the past 5 days as well as a forecast out to 5 days. On the very top are three main sets of links. I'll come back to these, the hydrology, weather, and climate links. I want to point out what our webmaster has really put together in terms of not only river forecasting, but also in terms of water resources, this long-term water supply outlook that I was mentioning earlier. Right here is a real quick look at what we're expecting for this current water year of 2019, given the current kind of dry start to that we've had, also looking at the rainfall that happened over Thanksgiving, as well as into the coming weeks, because these also include forecasted rainfall. But you can see we're somewhere anywhere between mostly 70 to 95% in a lot of our watersheds. And that can be just a real quick overview of how the state is doing in terms of water resources. I want to move on to some of the things that Julie was showing earlier. If you wanted to kind of see how much snow fell over the last 7 days, SWE here stands for the snow water equivalent, so how much water is in the snowpack. And you can zoom into various basins. And some of these zeros, again, we're an operational office, so some of these are probably bad gauges that haven't really been reporting at all. But some of them probably are good in the sense that so far the snowfall has been limited to more higher elevations. And so you can click on any one of these locations and see here at Squaw Valley, we have about 7 inches of water equivalent that has already fallen, but that's at a pretty high elevation at 8,000 feet. And so you can do a little bit of analysis as to where the snow is and how much is there. And then you could also look at what's the current percent of normal, which Julie showed earlier. And again, up here at Squaw Valley, that 7 inches translates to an above average snowpack for this time of year. It's a pretty early in this season to start getting these larger storms. So that's a quick look at the snow. Precipitation is certainly the thing that most people are going to be interested in. Again, we're an operational office, and so you can see this is our raw, unquality controlled. We're looking at about 18 or 1,700 rain gauges up and down the state of California, Nevada, as well as into Oregon. And you can see what's happened over the last 168 hours, so the last 7 days, including that storm over Thanksgiving. You can see quite a bit of rain has fallen. And if you wanted to kind of then see, well, what does that translate to in terms of a percent of average? These are a monthly percent of averages, but notice also that these are a more smaller set of rain gauges, only a 340 or so, but shows a different percentage of averages for the month of November. And then if you want to look at that in terms of a gridded look, you could also click on this tab, see the grid of how does that rainfall look for the month of November, or perhaps for the entire water year. And again, still, as Julie was saying earlier, mostly below normal, but there's some pockets where we're starting to catch up to normal, which is a good sign. So that's snow and rainfall. You could also look at our forecasted rainfall that we're expecting in the next 6 days, and if you hover over you should be reading the actual amounts there. And then other things on here, temperatures, I won't go into, freezing levels. Again, a lot of this is kind of geared towards, temperatures are interesting when you're looking at snowmelt flooding, flash flooding. The final one here that might be of interest in terms of drought is we do have a way of looking at not only the U.S. Drought Monitor, but also the Climate Prediction Center's outlooks, both for this month as well as a seasonal outlook where the improvement is expected and where drought is expected to persist, things like that. But I want to jump really quick to, again, the whole niche that I think our office has is this area of water resources forecasting. And so on these tabs at the very top, if I want to look at climate forecast, I'm usually jumping right here. It's a nice spot to kind of see, as I think both Julie and Amanda were mentioning, we're forecasting. If you want to see all the CPC outlooks in a real quick way, we have the 6 to 10 day, the 8 to 14 day, the new experimental 3 to 4 week outlook that CPC produced, as well as the monthly and seasonal outlooks, all on one page. And that can be really helpful, quick tour of CPC's forecasts. Again, moving to a hydrology, this one link here can be really valuable in terms of understanding how does all this translate into the water supply for California. If you click on water resources, a lot of these products will be repeats from what we've just seen already looking at the front page. If you want to look at precipitation, the default here is to look at the watershed averaged precipitation. So this is taking each of those individual gauges and then mapping them into actual watersheds to see what is our percent of average of precipitation over the last almost 2 months now. And you could also check out some of the, we worked closely with the Department of Water Resources, and some of their indexes, the Northern Sierra Index is a key water supply indicator. If you wanted to just make a quick jump over to their website, we have a link there. If you click on that, it'll show the Northern Sierra Precipitation Index, which is a graph here of this blue line showing that with the recent storms, we're now up to 5 inches, which is about 60% of average for the state. So still behind average, but moving in the right direction. And then also the individual point, a different look at how to look at individual rain gauges with this map here. And then again, snow we've kind of covered once already. I'm going to move on to observed flow. Again, this map showing our observed flow with the dry start to the water year is well below average. You could also check out reservoir storage, both the major reservoirs. Again, the size of these circles indicate the capacity of each of these reservoirs. We include a couple Colorado River reservoirs as well. And then finally, again, our water supply forecast. This would take a much longer time to describe, but in general, if you click on any one of these dots, you'll end up with a river basin forecast. We also have these squares, which are compilations, or condensing a lot of information or a lot of watersheds into one index. This one is followed closely, the Sacramento Valley Water Resources Index. And every day we're looking at a year's supply of water. How is our water supply shaping up? And these green X's indicate whether we're going down in our forecast or going up. And so you can see it in mid-November, our forecast were continually getting drier with our dry start to the water year, but now they've been going up as things have gotten wetter. And so currently we're looking at about 15 million acre feet of runoff as a best guess, most probable, but although the range of that could go anywhere from very wet to still very dry. And it's very interesting. You can also look at past water years and see how those have developed. For example, last year we were looking very, very dry here in February, but then these green X's started to go up as we got wet in the month of March. And so that can be a real helpful way to look at where our water supply is going. And with that, I'm going to stop because there's running out of time. So I'll hand it back to you, Amanda.
Thanks, Pete. I think I got a quick question for you while I'm changing over to the other speaker. Someone asked, is there a similar site for Oregon or Washington?
Yes, the Northwest River Forecast Center would have a similar site. So if you typed in a Google search for the Northwest River Forecast Center, they also have a website. It's very different than ours, but you'll see a lot of the similar information.
Thanks, Pete. And then our last little tool for right now is going to be Julie Kalansky again, and she's going to talk about CNAP's tools as well as the Center for Western Weather and Water Extremes, especially some of their AR forecasting tools, which I think will be of interest to the group. Julie, I'll pass control over to you.
Great, thanks, Amanda. So I'll do this pretty briefly. Hopefully right now you can see the CW3E, or the Center for Western Weather and Water Extremes website. It's just cw3e.ucsd.edu. And I'm going to highlight a lot of the forecasting tools. A lot of the work that we do here is focused on atmospheric rivers. And so how you would get there, if you go to Forecast, AR, IWV, IVT Forecast. So if you click there, you can see, and these are looking at water vapors forecasts from different models. You can select the models, and this is looking for IVT, so the amount of water and transport, and which is an indication of atmospheric rivers. And you can see it at a bunch of different, if you click on this, you can see it at a bunch of different time steps. So you can see how it will evolve. I'm going to go back and go down quite a bit. There's a lot of here to cover, and I would encourage especially the weather nerds to really take some time and play around with the website. There's quite a bit of information, but I'm going to highlight some of the more popular tools that the group has, and this is the AR landfall tool. I showed it in my presentation. This is looking at the probability of an atmospheric river making a landfall along the U.S. West Coast. And so there are 21 ensemble members, and so this is what percentage or what fraction of those show that an AR is likely to make landfall. And then you can see the dots along the time. The red here indicates that it's at least 99%. The black is 75%, and the gray is 50%, and so this is the duration. So this is out to 24 hours or to 63 hours. And then you can also play around at the thresholds. And so, for example, 500 is a much stronger moderate AR. There's also an inland row that you can see if the AR is going to penetrate inland, and the likelihood of that, which this one is like appears to, especially between Washington and Oregon. And then there's some new, more experimental ones that are showing the vectors. And so this is the direction of the AR as well. And you can also take it out to, for the regular ones, you can take it out to 16 days. Though I will say with a caveat, out beyond, much beyond 10, even 8 days, there's a lot of uncertainty around here. So take these with a grain of salt. The other one that's pretty popular are the plume diagrams. And so what this is showing is these are all the different ensemble members. The red is the max, the blue is the minimum, the black is the mean, and the green is the control. And so if you pick a location, let's just say somewhere in Northern California, so this is looking at the threshold for an AR and what the uncertainty is. So for example, this is 250, which is between 250 and 500 is a weak AR. Oh, sorry. And then between 500 and 750 is a moderate, 750 and 1,000 is strong, and then we go into extreme. And so this just shows the uncertainty around a certain AR, both in terms of strength. And so, for example, for the IVT here, there's quite a bit of certainty. There's not a lot of room between the minimum and maximum. And so you can see that, and also in terms of the duration, so how long it will be. Again, there's not a lot of uncertainty of when it will start. There's a bit of when it will cross 250. So there's a couple hours here, but this example later in the week shows where there is quite a bit of uncertainty between whether or not it'll even cross that 250 threshold and even be an AR, or it won't be. So that here you do see quite a bit of uncertainty. So this is one way to get a sense of how certain the at least the atmospheric river forecast is. The other thing, so if you go back to the top and you can click up here, it goes back to the home page. Another really cool tool is the interactive maps. And so if you click on this, there's a lot here. I will show two real quickly. One is this watershed precipitation. So this is similar a bit to what Pete was showing, but you can click on different watersheds. And this is showing the 10-day forecast in terms of millimeters from the color. And the dots on here are the gauges from the CNRFC of no flooding, minor flooding, if there's a big storm coming. So this is taken from the CNRFC data. And so this is looking, for example, at the San Joaquin Rivershed. These are 3-hour precipitation totals, which are these gray bars. And the red bar is accumulation of water over the watershed. And then if that's averaged, it's calculated into acre feet. And so that's assuming perfect runoff. There's a lot of assumptions in there, but that just gives you a sense of what the potential runoff would be from the forecasted precipitation over a whole bunch of different watersheds. And then the one last thing I'd like to show or I guess second to last thing for the website is this freezing level tool, forecast tool that came out last year. So this was developed by Brian Henn and Jay Cordera. And so there's a lot going on, but it's really interesting. So this is looking at a watershed, and each one of these lines is a different ensemble member of the snow level. So above this line is where snow will fall, and below is where it will fall as rain. And this has big implications potentially for flooding, because if it falls as snow, the precipitation is less likely to run off quickly and have less of a flooding risk, whereas if it falls as rain, there's more potential for flooding, especially during extreme events. And so what this is looking at is the reds are the warmer and the blues are the cooler forecast. And the green here is showing the percentage of precipitation. So the total precipitation is this bar that was likely to fall as rain. The light green is rain or snow, depending on the ensemble member, and then the white is the snow. And so you get a sense of how much of the precipitation coming up, for example, here between November 29th and November 30th will fall as rain or as snow. And then number at top is the total amount of precipitation anticipated. And so the last thing I would like to show, the other thing is we will often do updates and outlooks for upcoming weather events. So this was one that was posted right before Thanksgiving about the storms that were coming. So it talks about the meteorological conditions. This also uses a lot of the tools from the CNRFC webpage that when look at forecasted precipitation totals or the amount of precipitation that's fallen. It uses some of the CW3E tools to show the AR, as you can see the AR development here. And so it provides a summary of what's coming. And then also at the end of events, but sometimes we also do a summary of what actually happened. So these are, if you know an event is coming and want to find out more information, this is a good place to do it. And it's just right on that home page. If you scroll down a bit under the news items, you can see these updates. So with 3 minutes, so this will be really brief, I'm going to talk about some of the CNAP tools we have. So if you go to the CNAP website, which is, you can do cnap.ucsd.edu. You go to the home page, and then one thing I'll mention before I look at some of the tools, with the Western Regional Climate Center, CNAP and CW3 developed this El Nino Southern Oscillation update. So it talks about the current conditions and what it has meant for California or the West as a whole previously, it has a lot of caveats because there's a lot of variability between El Nino and what it means in terms of precipitation for our region. But if you scroll down a bit, you can go to the CNAP Drought Tracker, which highlights a lot of the tools that CNAP colleagues and researchers have developed over time. And so this is one of my favorite for general communication and just information. But if you click here, this was developed with CNAP and CW3E. It looks at the precipitation totals. So for example, you can see what a recent rain event has done. So this is for all of California. And right now it's 8.5% of normal precipitation. The 1-day change was 0, the 2-day change was 0.1%, and the 3-day change was 0.67% of normal. And so you can see how the precipitation has changed over time. Here's a figure that compares it to the 2/3 of years, all years, so you can see how this year compares. And there's a bunch of different stations. So there's all of California, there's LA, San Diego, the 8-station index, which Pete mentioned previously, and then for Clark County, the Las Vegas area, and the Reno-Carson area as well. So depending on where you are, there's regional, and you can easily see how a certain storm or a couple of storms impacted precipitation. And then this is a tool where actually if you click here, you can get your own map, but it's what's the likelihood of reaching median, so the 50th percentile of precipitation based on the precipitation we've had thus far. And so the tool was developed by Nina Oakley, and she periodically updates this after storms. You can find it here at the Drought Tracker. So Dennis Lettemeyer, who's a CNAP researcher at UCLA, has the Drought Tracker, which again, you can find out more information, but this is the SWE percentile, and this is modeled using a hydrologic model. But this is just to see what current conditions are. This is something that I showed on the Outlook. So this is the amount of reservoir plus snowpack. And then if you click here, what Mike Dedinger has done is he's also started to break it down from northern Sierras to central Sierras to southern Sierras. You can see how it breaks down throughout the state too in terms of reservoirs and snowpack. And then also too, which I didn't show, but this is looking at soil moisture. So how does this soil moisture compare to historically? So these are all in percentiles. And again, this is from Dennis Lettemeyer at UCLA and his group. And then from here, you can also link to some of the CW3E websites in terms of if there's rain forecasted and coming. And so this is the drought tracker from the CNAP website is one place to be able to go and find a bunch of information. And I will stop there because I know we're after the hour. Apologies, Amanda, but thank you.
Yeah, that was great. Thanks, Julie. Let me steal a presenter from you real quick. And that brings us to the end of the webinar. I do want to say we can take a few more questions here. If folks want to go ahead and type them in, just stay around. I know we're after the hour, but if there's a few burning questions, we answer them there. Or feel free to contact our speakers. Thanks, Julie, Pete, and Michelle for great presentations today. Just want to remind folks that the recording of this webinar will be up on drought.gov later this week, and our next webinar is scheduled for Monday, January 28th. So we'll see how conditions occur over the next 2 months and what's going on. And you can find out registration for that already open on drought.gov, or it'll go in the post-webinar email as well. But let's see. I don't see any questions popping up though. So feel free to contact me if you guys have more. Otherwise, I'll go ahead and close the webinar, and contact me if you'd like more information about the drought early warning system or any of the other activities going on. So thank you, everyone.